All right, here's a video for the Unit 8 practice test for correlation and regression. So concept A, I can estimate a line of best fit and use it to make predictions. So we have a table that represents the number of snapshots sent over the course of 7 weeks. So the first thing we're going to do is we're going to make a scatter plot of the data, and we're going to label our graph. So in this case, the independent variable is time, so that's going to go on the x-axis, and we need to go from 0 to 7. So I think we should be able to fit, if we just number it by every 2 is 1 unit, or 1 week, I guess. So time in weeks. And then the y-axis is going to be number of Snapchats. So for this, we need to go from 0 to 270. So I'm going to go start at 0, and every 2 is going to be 25. So this is 50, 100, 150, 200, 250, and 300. So you just need to make sure your scatter plot can fit all of your data. So now I'm going to graph it. So first one is 0, 0. Then I have 142. So you're going to have to kind of estimate 284, 3, 117, 4, 146, 5, 190, 6, 235, and then 7, 270. Okay. Now we need to draw a line of best fit and write the slope-intercept equation for it. So this is where yours might differ depending on how you draw your line, but we're going to draw a line of best fit. So to me, it's almost linear. It could look something like this, maybe. Just make sure your line is as close to as many points as possible. Okay, so let me adjust this just a tiny bit. Okay. Remember, your line does not have to go through any points, but it can if it needs to. So now let's figure out what is our slope. So to figure out our slope, we're going to pick 2 points on the line. So we're just going to see on the grid where we see 2 points. Let's see, since we go through 0, 0, might as well pick that point and then maybe this point right here. Okay, now we're going to figure out our slope. So this, we go up 3 boxes, but remember every box is 25 units. So that's actually going up 75. And then here that's 1, 2 units. So my slope is going to be 75 over 2, which is 37.5. And my y-intercept, I cross at 0, 0, so that's going to be 0. So my equation is y going to be 37.5x plus 0, or you can just write 37.5x. All right. Part C says give a reasonable correlation coefficient for the line. Explain how you came up with this. So I would say that these points follow a linear pattern pretty strongly, and they're very close to the line. So I would say this is a strong relationship. So I'm going to say 0.95. And my reasoning is the points are close to the line and follow a positive linear pattern. Okay, now it says predict the number of Snapchats after 13 weeks. So weeks is our x variable, our independent variable, so that means we're just going to plug it in for x in our equation. So it's going to be y equals 37.5 times 13. Oops. And that's going to be 487.5. And since it's number of Snapchats, we can just round that up to 488. So after 13 weeks, 488 Snapchats will be sent. All right, the next question says, if someone has 500 Snapchats, about how long have they had Snapchat? So the number of Snapchats is our y variable, so that means we're going to plug it in for y in our equation. So that's going to be 500 equals 37.5 times x. So all we need to do is solve for x, so divide by 37.5. So x is going to be 13.33. So if someone has 500 Snapchats, they have had Snapchat for 13.3 weeks. All right, so now let's look at concept B. I can determine and describe correlation and causation for a situation. So data collected from online surveys showed that people who ate an excess amount of calories gained weight. It could be concluded that eating too many calories can cause weight gain, but what are two or more confounding variables that could affect this conclusion? So remember, a confounding variable is something that makes something look like causation or something that could be attributing to the relationship. So it says ate an excess amount of calories, gained weight. So other things that might affect how much weight that you gain is your genetics. And another thing that could affect how much food that you're eating and weight gain could also be how much you exercise. All right, second question, it says that ice cream sales go up during the summer. The crime rate also increases, so then it could be concluded that ice cream sales cause an increase in crime rates. But what are two or more confounding variables that can affect this conclusion? So one thing could be the temperature outside. Right, when it's hot out, more people are eating ice cream, but maybe more people are out and about, more opportunities for crime. And then maybe the fact that people are out of school or kids are out of school. So they're eating ice cream because it's summer, and then also can be out and about unsupervised doing things that maybe they're not supposed to be doing. All right, number 4, it says which statement suggests causation. So out of these statements, I think the one that, you can argue in any case that it's not necessarily causation, but I would think that the one that is most causation is B. When you eat fast food, you gain weight. And instead of writing my explanation, I'm just going to say it. I think the reason for that is because fast food is high in calories, and if you eat in excess of calories, you'll gain weight. So of all these statements, I think B is the one that is most like causation. Okay, last one here. Which correlation coefficient best matches the scatter plot shown? So if we draw in a line of best fit, we can see that those points are relatively close to the line, which means it's a stronger rather than weak relationship. I also know that it's negative, so it can't be A and B. And a stronger relationship is going to be close to -1. So my explanation, I'm going to say it's negative because the points are going down. And then I'm going to say that it's a moderate or strong relationship because the points are close to the line. All right, now we're on to concept C. So in concept C, we are finding the mean and the median. So to find the mean, we're going to add these all together. So 3 plus 6 plus 7 plus 9 plus 11 plus 12 plus 14. And then to find the mean, you divide by the total number of numbers. So that's 1, 2, 3, 4, 5, 6, 7 numbers. So that divided by 7. So when you add those all up, you get 62 over 7. That's going to be 8.86. So that's going to be the mean. And then to find the median, you look for the middle number. So these are actually already written in order. So one way you can do it is you can kind of cross off from both ends until you meet the middle. So that means 9 is the median. All right, same thing for B. We're going to add these together. And if you count the total number of numbers, it's 10. So when we add those all together, we get 47 divided by 10, which is going to be 4.7. So that's the mean. All right, to get the median, we have to put these numbers in order. So I'm going to put it in order. And now we need to find the middle. So again, I like to kind of cross off from both ends. So then in this case, since there's an even number, we have two numbers in the middle, so we would just find the average, 4 plus 4 divided by 2, which is just going to be 4. So that means my median is equal to 4. All right, so in terms of finding the mean of the data set, so as I said before, I'm not going to write it out. To find the mean, you add up all the numbers and divide by the total number of values that you have. To find the median, you have to first put your numbers in order from smallest to largest, and then you're going to find the middle number. All right, next question says create a data set with median of 12. So that just means we need our middle number when the data is put in order to be 12. So an example would be this data set. As we can see, 12 is in the middle, so that's the median. All right, now let's talk about data distribution. So remember, the direction of the skew is the side that the tail is on. So if we can see in this data set that the tail is on the right-hand side, which means that it's skewed right. So my explanation would be tail on right. Remember, when we have a skewed data set, the best measure of center to use is the median. So my explanation would be because it's skewed. All right, box plot. Same thing, we're looking for the tail. So as we can see, we have a long tail on the right-hand side. That means it is skewed right. And again, the best measure of center would be the median. If it were symmetric, we would use the mean. All right, moving on to concept D. So concept D is I can create and interpret various data displays. So number 1 says construct a box and whisker plot of the data set. So to determine the 5-number summary, which is the minimum, maximum, median, Q1, and Q3, we first need to put our data in order. So I'm going to put it in order. Okay, now we should be able to identify these things. So my minimum is here, that's 4. My maximum is going to be 20. And then my median, I'm just going to cross off until I reach the middle. So my median is going to be 18, in particular that first 18. Now for Q1, we're going to look at the bottom half of the data, and we're going to find the middle there. So the bottom half of the data is going to be between 10 and 12. So one way to find the median, like I said, is, or Q1, you can add those together and divide by 2, or we can think of what's in the middle between 10 and 12, and that's going to be 11. And then for Q3, we're going to look at the second half of the data, and we're going to find the middle. So the middle of the second half would be between the 19 and the 19, which means Q3 is going to be 19. All right, now we're going to make our box plot. So our box plot needs to start at 4. I'm just going to go by 2s here. We just need to make sure our graph goes up to 19, which it does. And then to make our box plot, start with the minimum and the maximum, so 4 and 19. My median is going to be 18. Q1 is going to be 11. And then Q3 is going to be, my maximum is 20. And then my Q3 is going to be 19 here. So my whiskers are on the end, and then I'm going to draw my box. So as we can see, this is a skewed left distribution because I have a long tail on the left-hand side. All right. It says find the 5-number summary of this data, and the box and whisker plot describes the number of books per student, a class checked out from the school library in one month. So it says according to the box plot, what percent of the students checked out between 6 and 8 books? So remember, with a box plot, every part of the box plot is 25%. That's why they're called quartiles, meaning 25% of students checked out books between 4 and 6 books. 25% checked out between 6 and 7, et cetera, et cetera. So if it's asking what percent checked out between 6 and 8 books, it's looking here. Well, in terms of percent, that's going to be 50%. All right, let's do the 5-number summary. So the minimum is 4, the maximum is 14. Median is this line here, that's at 7. Q1 is at 6, and then Q3 is at 8. All right, now we're going to construct a histogram. So histogram, we're going to put weight down here. And as we can see, our bins are basically every 10 units. So this is 10, 20, 30, 40, 50, 60. And in the first bin between 0 and 9, there's 5 dogs. So, and we know that this needs to go up to 35. So I'm going to go by 5. So this is 5, 10, 15, 20, 25, 30, 35. This is number of dogs. So my first bin is going to be 5 dogs. My next bin is 15. Then I have 24, which is about right here. Then 35. Then I have 16. And then 6. So it says, what weight was most common? Well, most common is going to be between 30 and 39 kilograms. And it says how many dogs weighed at least 30 kilograms. So at least 30 would be 30 and above. So we would be adding together 35 plus 16 plus 6, which is going to be 57 dogs. All right, now we are in the last concept, which is I can model interpret 2 variable data. So we have a table here that represents individuals in terms of what time they shower and whether they show up early, late, or on time. So to make a two-way frequency table, I'm going to put how they show up, so early, late, or on time. And then I'm going to put day and night here. Okay, so now I'm just going to tally. So the first individual showers at night and they show up late. Next individual showers during the day and they arrive on time. Then day early, night early, night on time, day early, day late, night late, night on time, day early, and day on time. So in total, we have 3, 1, and 2, and then 1, 2, and 2. So now we can do our total. So 3 plus 1 is 4. This is 3, 4. And then across, we have 6 here, 5 here, for a total of 11 individuals. We can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So now to make a relative frequency table, so we're going to keep our labels the same, day and night, and then early, late, and on time. What we're going to do is we're going to take all of the numbers inside of here and divide by 11. So for instance, here we're going to, and then multiply by 100 to make it a percent. So 3 divided by 11 is 0.27, and multiplied by 100, that's going to be 27%. So I'm just going to fill it out. This one is going to be 9%, 18%, 9%, 18%, 18%, 55%, 45%, this is 100%, 36%, 27%, and 36%. Okay. So now we can answer these questions. It says, how many night people show up late? So night show up late, that's going to be 2. How many people who shower at night are not late? So night, not late. So not late would be, I guess, earlier on time. So that's going to be 1 plus 2, so that's going to be 3 people. What percent of people who are on time shower during the day? So now we're looking at the relative frequency since it's asking for a percent. On time, shower during the day. That's going to be 18%. And then it says, what percent of night showers are early or on time? So night showers, again, early or on time. So early or on time, so it's going to be 9 plus 18%. That's going to be 27%. All right, now it says construct a double bar graph from the two-way frequency table, label the axes, and include a key. So double bar graph, we are going to have basically 3 groups for the early. So say this is early. The next group is going to be late, and then the on time here. So double bar graph, meaning we're going to have 2 different bar graphs for one for day and night shower. So starting with the early, there's 3 day and 1 night. So 3 day and 1 night. So I'm going to say blue is day and red is night. And then for late showers or late arrivals, 1 day, 2 night. So 1 day, 2 night. And then on time, 2 and 2. Okay. Another way you technically could do this is you could group it by day and night and have 3 bars representing early, late, and on time. Either way, it's going to be representing the same data.